Uh, all right. Yes.
Yay!
So last meeting, we had an introduction of algebra. And I think I ended the discussion on showing you the properties of real numbers. As I mentioned, these properties are important as we go along trying to do some computations, simplifying of expressions in algebra. And so we talked about commutative property, and then just browse through associative, distributive, identity, and inverse. Yeah, just to remind us, I know some of you may have already still remember your different properties. So we talked about associative properties as that it says that when you add or multiply numbers, they can be grouped in different ways and the answer will still be the same. So if you notice with like when you want to add plus 5 plus 6 plus 1, you can add 5 plus 6 first before adding 1. And then, or you can add 6 plus 1 first before adding to 5. And your answer will remain the same. So that's just as simple as you can group in different ways and yet you get the same answer. Similarly, when you also do multiplication, you can group 2 times 5 first, do that before multiplying by 3, or you can first multiply 5 times 3 before multiplying by 2. The fact that anyway, these are also commutative operations, right? So that's how it is. And so when we now talk about distributive. All right. Distributive property, this is a very important law or property in algebra because when we do factoring, that's very important to fully understand the distributive law. Okay, so just for the sake of illustration, when I now have 5 times 3 plus 2, okay, let me just write that here. Okay. Okay, so we're saying, if you multiply 5 times 3 plus 2, that is actually multiplying 5. If you add 3 plus 2, that's 5. That's actually 25, right? So you know that 5 times 3 plus 2 is 25. But now because we're using just numbers, later on we'll be dealing with some letters. But according to the distributive property, just for our review, you can actually just multiply first 5 times 3 plus 5 times 2, which means that you are distributing 5. Multiply that over addition of 3 plus 2, which is actually 15 plus 10, and it's also equal to 10. So that one is easy when you are dealing with numbers. But of course, many times we will be dealing with letters. So it's just important that we understand that A times B plus C is the same as AB plus AC. Okay. All right. So just the same when we are subtracting. Okay. So just the same. We now say 7 times 6 minus 4 is actually 7 times 2, which is 14. This is just the same as multiplying 7 times 6 minus 7 times. So 7 times 6 is 42 minus 7 times 4 is 28, and 42 minus 28. That's remembering our distributive law, right? Yeah. And therefore, when we are now dealing with letters, we'll talk more about that in our discussion. So when we're dealing with letters, then you now say it's that minus 3 times 2x plus 4y. If it were not distributive, you cannot really add 2x plus 4y in a way there, because these are two different mathematical expressions. But the distributive property saying is just multiplying minus 3 times 2x, all right, plus minus 3 times 4y. Yes, so minus 3, we have learned about multiplying unlike times. So minus 3 times 2x gives you minus 6. And this is now minus 3 times 4y. That's also negative. So that is now minus 12. It's minus 6x minus 12. So that's just an illustration of our distributive property.
And
Yes?
with that last problem, that's the end.
Yeah.
Because you can't go any further because one is x and one is y, right? And we
Yes,
don't
the
have any
other
other
one is.
information.
Mhm.
That would be
Forward.
that problem. Okay.
So it's minus 6x minus 12y. So these are two x, you know, in we'll talk more about dealing with algebraic expressions later on. So we now cannot combine anymore. So your answer will just be really minus 6x minus 12y. All right. Let's now proceed. So now let's proceed to algebraic expressions. So in algebra, I think we really learned that even in your high school algebra, that we deal with letters. So an algebraic expression is, of course, an expression that includes algebraic terms. And when we talk about algebraic terms, it can be letters, it can be groups of letters, as well as numbers that can be separated by addition or subtraction. And so when we are dealing with just number, we call that a constant term. So, you know, notice that we have an example here, 5x plus y minus 9. So the combination of letter and number is an algebraic term. So we now have 5x. And so in an algebraic term, you have a coefficient, which is the number, and a variable. So that for the term 5x, 5 is the coefficient, x is the variable. Now, if a certain algebraic term has just a letter, it is understood that the coefficient, which is the number that is associated with it, is a 1. So therefore, the y is an algebraic term where 1 is the coefficient and y is, of course, the value. And you have a 9, which is a constant. So that's what is an algebraic term, is having a coefficient, which is the number that precedes the variable is your coefficient. And then, of course, the letter is your variable. So we'll be dealing more of algebraic expressions in our discussion. All right, now, so please know that these different letters or the variables may represent a value or any given number, so that we're able to evaluate algebraic expressions if you are given the value for your variable. So that an example here on my letter A, I have now y plus 3 divided by y minus 3. If y is equal to 5, this means that we'll just have to substitute y. Instead of y, we have to put a 5. So that's just a simple algebraic evaluation. 5 plus 3 over 5 minus 3. That will give you 5 plus 3 is, of course, 8. And 5 minus 3 is 2. And 8 divided by 2. So that's evaluating the expression for the given values. Right? So, yeah, let me see. Will you please try letter B? substitute -2 for t.
Oh.
-2 is +4, 7 times 4 is 11.
There you go.
All right, that's your answer. So instead of t, yeah, instead of t, we put at -2.
Mm-hmm.
Mm-hmm.
Who wants to give an answer?
It's 11 for B.
Oh.
Did everyone get 11?
Yeah.
Yep.
Yes.
Oh. Oh.
Yeah, because we now
So
have
you
7 minus
And then
2 and multiply that by -2. And negative
Plus
times
4.
negative is positive. So we'll now have 7 plus 4 is equal to 11.
Mm-hmm.
That's great. All right. Okay, how about letter C now? Pi is a constant. So it's so you don't have, you know, the value for pi, 3.1416, something like that. So in here, I expect that your answer will still have a pi. Yeah, I hope that you have a calculator, but you can use also your phone as your calculator. So that letter C is 1/3 pi is actually your coefficient for your variable r, but that variable r needs to be squared.
Ah.
Okay, let me see what will you do there. Okay, so when you say squared, I will talk more about these exponents later on, but I just, because anyway you had experience with algebra previously. So let me see.
This is this is the part of pi.
So when you say
R2.
r squared, what does that mean? You'll have to multiply
11 by 11.
11 by itself. So what is 11 times 11?
121.
Yes. Okay. So what will be now your final answer?
You got it?
When you said 11 times 11 is 121. So final answer will be, just combine that 121 times pi over 3. The final answer will be now 121 over 3 pi.
Oh, that's it. Okay.
Just stay with the pi. So
Mhm,
11
precise.
times 11 is 121. And multiply 121 times 1/3 pi. 121 times 1 is 121 times pi over 3. Or you can actually just even write it as 121 pi over 3. They are just.
Figure is like 1/3 times pi times 11 squared over 1.
Yeah.
3. What did you get? 380?
No, it's just
Hmm?
you just divide that by 3. That's all. So that's the
Just
final answer. 121 pi over 3.
Oh, okay. There you go.
Leave it that way. You can have put the pi just at the side, or just that this other thing that I have written 121 pi over. This final. This one can be the answer. All right, this one can also be, you can put it that way. No problem.
So wait, either of
Yes.
those are the answer. Okay, good.
Any, yeah. You can write it as 121 over 3 pi, or you can put it as 121 pi over 3. Leave it that way. We don't have to multiply 121 times the value of pi. Leave pi as a constant because we understand that pi is a number. Yeah, it is a constant. Leave it.
Does that always apply when we're using pi or no?
Not really, especially when we now solve some problems later on. You can, sometimes I would ask you to substitute the value of pi. And would say, maybe I would just let pi be 3.14, or I want pi to be 3.1416. But so the moment, let that pi remain as it is. So this is now the 121 pi over 3 is already a constant because we know that pi. Why don't we try letter D? P squared Q cubed.
What?
That number, letter D. P squared Q raised to the third power, where P is -2 and Q is -2. Perhaps let's try to do that together. So we now have P squared Q and we raised it to the third power. Our P is -2. So you now have -2. We square that. Then we multiply by Q, which is a 3. And the answer, we have to raise it to the third power.
So it's
So when we multiply -2 times -2, that will become +4, right? Negative times negative is positive. So it will now be 4. Then I multiply that by 3. And then we cube it. So 4 times 3 is 12. And raised to the third power, which means that we multiply 12 by itself 3 times. 12 times 12 times 12.
Which is 1,728.
Yeah. The final answer is 1728.
Yep.
Yes.
That's what my calculator said.
Yeah, I think we really need a calculator, but your phone has a calculator. So, but anyway, next time it will be better to, because maybe later on we'll do a few things that may need a little bit more complicated. But no, we won't. The calculator in the phone would suffice. 728. Did all of you get that?
Yeah.
I'm just trying to, I think for anything.
So 1728. 12 times 12 times 12.
Huh?
Yes, very good.
Oh, I understand now. Okay.
Now let's try some fraction. Well, I think you know how to operate fractions. And I just gave fractions here with the same denominator. So you know that if they have the same denominator, you just have to add or subtract the numerator and you will get, and your denominator is common. Try letter E.
Is the answer 3?
Good. Yes. Let's wait for the rest. The answer is supposed to be 3. Try doing that for the others. I'll give you some little time. So the answer is 3. But it's just good to work it out. following the principles of operations on signed numbers.
That's why I got it. No, wait, that's right. That's right. Oh. What was I thinking?
Who else then you get 3?
Yep, I got 3.
Yes, good.
No, right. Okay.
So let's just try. Okay, just for substitutions, they have 4. Instead of m, we put 2 over 3. Instead of n, we put 1 over 3. Right? So m minus n minus 5. Then your n is 1 over 3. Your m is 2 over 3. Okay. So 2/3 minus 1/3 is 2 minus 1 because they have common denominator. So you just have to subtract the numerator. So 2 minus 1 is 1/3. All right. Minus 5. Then you have 1 minus 2. I think last meeting we said this time you'll subtract and then the answer will follow the sign of the bigger number. So 1 minus 2/3 will now be minus 1 over 3 because 2 has a bigger value. Right. Then we multiply 4 times 1 over 3 is 4/3. But then you have minus 5 times minus 1 or negative 5 times negative 1. That will become a positive. So following our rules for sign numbers. And so 4 plus 5 is 9 divided by 3. And therefore you get 3 as an answer.
Yay.
Is that okay?
Yes.
So this is what we mean by evaluating algebraic expressions where your letters would represent numbers. And so the given value should be just distributed to the letter and you can now do the evaluation. Is it okay?
Yep.
Right. So I think we can proceed. There are exercises in the book that you can work on if as you know as we move along.
What page?
No.
We are just on the first section. Yeah. So at the end of the, I think I'll give some exercises for you to work on as part of your homework for this section. I will check later on the page. But anyway, so let's now proceed. Okay. So that's what we mean by algebraic expression. And in our discussion, most of the things that we'll be dealing with would really not just numbers, but very much expressions, giving variables and coefficients. All right, a more useful concept in algebra is equation, where you now have a statement indicating that two expressions are equal. We will not yet compute equations here, but we just want to show some examples of equation. Yeah, so the equation may not really it's a proposition, all right? You're now saying when you substitute a value, you can make it true or false. You know, if your answer is wrong, then your equality will be false. If your answer is correct, then your equality will be true. But just to talk about the terminologies, because you know, algebra or math has its own language, and so we need to understand this language. All right, this language in algebra. So we talked about algebraic expressions. So an equation is composed of expressions where you now have a variable, we have a coefficient, we have the operator, whether it is a plus or a minus, and its the expression there is considered to be a term. All right, it's an element of the expression. So just the terms there. So let me repeat, the constant that is associated with the variable is called the coefficient. And so the numbers are the constant. So an equation is composed of different terms of an expression with an equality sign. So that's an equation. Now, in here, its formulas are composed of equations. A formula is an equation in itself. And so just some examples of equations that would express a relationship between constant and variable quantities that many times we use as a formula. And it is the aim of algebra that you yourself can model problems by deriving your own formula. But there are formulas that had already been used. And one of this is, of course, the quadratic formula, which we will be using when we move on to quadratic functions. And that's an example of a quadratic formula where, given a quadratic function or a quadratic equation, you can solve for the value of x. These are just examples. We'll be dealing with this later on in I think this is chapter 3 or so. Now there are lots of geometry formulas, looking for the perimeter of a square, perimeter of a rectangle, circumference of a circle, areas of geometric figures of square, rectangle, triangle, trapezoid, circle, or surface area or volume. So just examples of formulas, and we will be dealing with these formulas. And one thing with algebra is you can make your own formula out of a given problem. And that's what we'll be learning in our discussion right here. Right. And so just for the sake of using a formula in solving a problem, I have this problem on a photograph. Sure, no, most of you are into media, but anyway, a photograph with length L and width W is placed in a mat. So with 8 centimeters, and the area of the mat is found to be, now this A is equal to L plus 16 times W plus 16 minus L times W was derived. That's what I'm saying. As of the moment, let's accept it that had been derived. I still don't want to preempt because it will come when we do model real life problems later on. But this is a model of this figure 4. And so the formula had already been derived, and that is L plus 16 times W plus 16 minus L times W. So the question that is asked is, what will be the area of a mat for a photograph with the length of 32 cm and a width of 24 centimeters? So you are given the values of the length and the width. So you want to find the area, substitute the values of the length to the formula L plus 16 and the value of the width minus L times W. So this is just the same as evaluating an algebraic expression. All right, so now substitute the values of L and W and then give me the answer.
Is it 1888?
18.
1888. Try again. L times W, length times width. Okay. So try again.
That's good.
So instead of L, put 32. Instead of W, put 24. Actually, you can write that L times W as like this. It's multiplying length times width.
Oh. I didn't understand. Okay. Uh-huh. Why didn't you do
Anyone who has an answer?
Is it 1,152?
Yeah?
1,152?
Yes. It should be 1152.
Yay! I did something. I understand it.
Next job, I'm gonna give you a gold star.
I want a cookie.
He's like, I'm hungry. I don't want no star. I want food.
Oh, did you get 1152?
Video is not
Yes.
amused. Jordan cookies.
Yeah, let me just erase that. Okay, how did get 1152?
You got,
We did.
no, like, how do you?
Oh, how?
Just replace the numbers instead of.
So
we did 32 plus 16.
All
Times
right,
24
so
plus
32 plus 16 times 24 plus 16 minus
Minus
32 times 24.
Let's go.
So then I did 48 times 40
48
minus
times 40, right? Minus, what is 32 times 24?
You didn't do that part. You missed. No, you didn't mention it though. You didn't multiply 32 times 24. You just went straight to the answer.
So 32 times 24, multiply.
768.
It's 768. Good, all right. 48 times
That's-
40 is?
1,000. Well,
You got
1,920.
1,920 minus 768. Subtracting
1,152.
all right.
11.
So that is now 1,152. And because it is cm times cm, you need to put the unit of measure, that's square centimeters. 1152 square centimeters.
yes, unit, like putting that label is always good because sometimes I get it wrong and not get points because of that.
Oh, yeah.
Are we okay?
really bit off.
the answer. No.
And then put the CM square. squared.
I got the answer, but there is that one stinking part.
Carelessness.
Carelessness.
Oh,
That's
yeah.
didn't.
So this is one
Very important lesson in math, all right? As I said, be accurate, okay? So, yeah, sometimes you just had some little, mixed up with a few things and multiplying too sometimes. So, 1152 square centimeters. So, you need that area so that you are able to put the photograph um, the photograph 32 cm by 24 cm, all right, where
And that's
the
the area.
width around is 8 centimeters.
Good.
It's okay? Yeah. So this is
Yeah.
another example of like evaluating an algebraic expression where now we are using that algebraic expression is a formula or an equation. Yeah, these are, I just want to do some illustrations. More things will come like this. And one nice thing about what we will be doing later on is we'll be given a problem and we'll figure out what the formula will be. Yes, we'll make our formula. Mhm. Right now, it's just given to you, okay? All right, we're good.
Yeah.
So we can proceed. Mhm.
That's what I was thinking, like, how do we turn that into that? So-
Yes. All right. Now, we already talked about some exponents. We did some operations on exponents a while ago, but then just to remind us of the different terms that we need to understand. And so when we now talk about that power that we put on top after the variable or after the number is called an exponent. So we call it a mathematical operation of repeated multiplication. So that when I have x to the n, your x is the base, which can be a number, and raise it to the nth power, where you multiply x times x times x so many times depending on the value of your exponent n. So therefore, like if I have 5 cubed, which you already did a while ago, then that would mean 5 times 5 times 5. And you multiply that by itself 3 times, and therefore you get the answer. So just for the term that we need to understand, we call the base as well as the exponent. Okay. Yeah. And now, so we will try to learn some rules of exponents. These are important as we evaluate some of our polynomials, monomial, binomial, and so on. So that when I say 2 squared times 2 cubed means I multiply 2 squared means 2 times 2. 2 cubed means 2 times 2 times 2. So how many times did we multiply?
5.
5. All right. And 5 is taken from the sum of 2 and 3. Okay? So please note. So in other words, we will consider a rule for exponent. And one of the rules is the product rule. And according to the product rule, for any real number A and your natural numbers M and N, I'm talking of natural numbers or, the counting numbers. The product rule of exponent states that if you have the same base and the base would be raised to powers like M and N, the product is just the common base and raise it to the sum of the two exponents. So you don't need to multiply. Yeah, what you say. So that's why we're now saying 2 squared times 2 cubed is the same as 2
The 5th power.
Yes, it's just the same as 2 raised to the power of 2 plus 3, which is 2 to the 5th. And so 2 times 2 times 2 times 2, then you now get the answer if you really want to multiply 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So that's a very important rule. Multiplying 2 bases raised to different exponents is just the base and raise it to the sum of the two exponents. Right. Okay, so just this. So if we now talk about expressions, okay. So if I say 2x cubed y to the 9 times 7x squared y squared. If you have numbers, multiply the numbers. So 2 times 7. And then put together the same bases, x cubed and x squared. Another base is a y. You have y to the 9 and y squared. So 2 times 7 is 14. And so x cubed times x squared is x to the 5th because you're adding 3 plus 2. Y to the 9 times y squared is y to the 11 because we're adding 9 plus 2. So therefore, the answer for 2x cubed y to the 9th times 7x squared y squared will just be 14 x to the 5th y to the 11th. So we only can add exponents if we have the same base. So you don't put together those different bases. So the x's will be put together and add the exponents just the same as y and then add the exponents. So that's one rule. We call this the product rule of exponents. I think that's fine? Okay. Oh, so this one, we can just say it loud without even doing any computation. What's your answer for letter A?
Take k to the 15th power.
Yes, k to the 15th. All right, now, your answer will just use the base. Do not simplify any further. Like letter B, what will be the answer?
2 over y to the 5th power.
To the 5th power. Yes. So if there is no power written, it's understood that the power is 1. So please take note of that. In other words,
Oh.
this one has a power of 1. There, I'm sorry. The power of 1.
Oh.
Yes. Let me erase that. I didn't write it nicely. Okay. So this is a 1. So that will be 2 over y raised to the 5th power. Good. And letter C?
E to the 14th power.
C to the 14th. Very good. All right. So that's how it is with the product rule. Okay, now let's proceed. Let's consider another rule. Okay, so let me begin from there. If I now have 5 cubed squared, it means that I multiply 5 cubed by itself 2 times. Right? So 5 cubed times 5 cubed, that's what it means. But then according to the rule of the product rule, you have to add the exponents, right? Therefore, your answer is 5 to the 6th. Now, what does that tell us? We call this the rule called the power rule. For any real number a and positive integers m and n, the power rule of exponents would be this way. A to a certain power and raise it to another power, you just have to multiply the exponents.
You're
So
just
a to the
multiplying
m raised to the n will be just a to the m times n. So that's why when you have 5 cubed squared, it will just be 5 to the 6. You don't even need to do 5 cubed times 5 cubed. That's not necessary. You know that 5 cubed raised to the 2nd power is just 5 raised to 3 times 2. Yes, so 5 cube raised to the 2nd power will be, sorry for that, 5 times 2, 3 times 2 will be 5 to the 6. So that's the second rule. We call it the power rule. This is times 2. Sometimes I write, okay, let me just erase. That's it. Okay, so just to illustrate that. Okay, so that's it now. When I have now 3 squared cube, you just have 3 raised to 2 times 3, which is 3 to the 6th. And when I have
That's
x
right.
to the 4th to the 5th, it will just be x to the 4 times 5, which is x to the 20. That's the second rule, the power rule. For the product of the same base with different exponents, add the exponents. But if you raise to a power, multiply the power of 1 to the one that you are raising to a power again. So that is now 5amn will be equal to 8 to the m times n. I hope that's right. That's a power rule. Okay. Let's proceed with another rule. Okay. This time it is division. So just to remember the meaning of exponents. When I say 3 to the 5th, that means 3 times 3 times 3 times 3. When I say 3 cubed, 3 times 3 times 3. But you see, you know that this can cancel there. 3 divided by 3, another 3 divided by 3, 3 divided by 3. What remains is 3 times 3, which is 3 squared. And so what does the quotient rule say? Whenever you divide two bases with different powers, 2 is actually just the difference between 5 and, I'm sorry, this should be a 3. 5 minus 3. All right. Sorry for that. 3 times 5 minus 3. Okay. So let me, I think I made a mistake in my let me just erase all ink. So I will now, this one is supposed to be minus 3. Okay. So the quotient rule says if you are dividing two bases with different exponents, you just have to subtract the exponents. Okay. So like this one, minus 50 x to the 8 y to the 10th divided by 10x cubed y squared. So you divide the numbers. Minus 50 divided by 10 is minus 5. X to the 8, x cubed. 8 minus 3 is 5. Y to the 10th, y squared. 10 minus 2 is 8. So you get your answer to be minus 5x to the 5th, y to the 8th. That is the expose rule. A quotient rule.
Can I,
Say, yes?
why is the final answer not 3 exponent 2, 3 to the power of 2? Like the first one, it's like the final answer is 3, 5 minus 2. I would have
No, it's
said
5 minus 3. I'm sorry. I think I made a mistake in putting in the. Okay, so let me just erase. So supposed to be, yeah, because I say this will now be 3, 3, yes. This should actually be 3 squared. This should have been a 3, 5 minus 3.
Yeah, I mean, it should be before 3 exponent 2. 3 exponent 2 should be the
Yeah.
last
The
answer.
only reason why I am saying this is I am just trying to illustrate that when I cancel out the 3, 3, 3, what remains is 3 times 3, which is 3 squared, which is the same as the final answer is
Yeah.
this. Yeah, you are okay. This is the final answer. But I just want to show that the 3 squared is actually, the 2 is from 5 minus 3. This is the final answer, 3 squared. I am just trying to illustrate that when you have you divide two numbers, the same base with different exponents, it's just copying the common base, and the power will be the difference between the exponent of the numerator minus the exponent of the denominator. The final answer is 3 squared. So I'm doing this in order to show the rule. That the rule means if you have the same base raised to different powers and you divide, you just have to copy the base and raise it to the power m minus n. The exponent of the numerator minus the exponent of the denominator. Is that, I hope
Okay.
yeah. So the final answer is 3 squared. Yes. Okay, so that's another rule. All right, just for remembering all the other things that we have done so far. Letter A, what will now be your answer?
S to the 7th.
Yeah, S to the 7th, because that is S75 of minus 68 is 7. Good. How about letter B? Just give me the base. Don't change anymore the negative to what? The base is -3. So what will that be?
-3 to the 5th power.
Yes. -3 to the 5th. Very good. How about letter C?
E,
EF, 2 times. It would be, 2.
EF to the 4th.
It would be EF to
EF squared raised to the
4. Well, EF squared
Wouldn't be s-
would raise to the 2, but EF raised to the 4.
all right. So
Yeah.
don't simplify further. I just want to we just want to say, so your final answer will be EF squared raised to the okay. Well, we can simplify that later on, but as of the moment, I want that answer. Okay, EF squared squared. Now, if you want to simplify, I don't want it yet because we have not done yet the the power of the product. So that's the final answer. Okay, just for the sake of illustration. Okay, yeah. All right. So that's the quotient rule. Let's proceed. Okay, let's try to work on another rule. When you say 8 to the 8, the 8 divided by 8 is equal to 1. Okay, now let me see. What number will you multiply 3 times? You get an 8.
An A? What?
What number that when you multiply 3 times by itself will give you an 8?
2.
Yeah.
2. Very good. So that is now 2 cubed over 2 cubed, correct? All right. Now, 2
Yes.
cubed over 2 cubed. Using the quotient rule, that is actually 2 raised to the 3 minus 3, right?
Mhm.
Because the exponent is 3. So we just use the quotient rule, all right? So 2, 3 minus 3. And 3 minus 3 is equal to 2, is equal to 0, correct? Yes. All right. Now, so 8 divided by 8 is equal to 1. So this tells us that 2 to the 0 is equal to 1. That brings us to the 0 rule of exponent, which you have to remember. We call it 0 exponent rule. That tells you that a number that is non-zero, you raise it to 0, your answer is 1. Any number raised to a 0 is equal to 1. So I just want to show why it is so. All right. Okay,
Thank you
so
so
let
much.
me erase now my numbering. Okay, that's it. This came from the quotient rule, that any number raised to a 0 is equal to 1. So that's a very important. Sometimes we call it not even a rule, it is a definition. 1 million to the 0 power is equal to 1. All right. 100 to the 0 power is equal to 1. And it came from that illustration that I have given to you. You know, that brings me to something like, you know, power. If the power is 0, then it will just be 1. And I think it had been said that there is power in prayer, right? There is power in prayer because we are praying to a powerful God. So that if you do not have prayer, Therefore, your power is 0. And if your power is 0, then you will just be alone. Okay? So, I just feel like, wow, this zero exponent rule. Anybody raised to a 0 power is 1, which is alone. And so I think I just want to remind us of what Ellen G. White is saying. No man is safe for a day or an hour without prayer. Reason is because you will just be alone. And of course, we know that prayer is putting oneself in the hands of God. So that's one thing on the 0 exponent rule. So just remember that anything you see 0 power, it will be equal to 1. Okay, so now let's continue. All right, now in our discussion a while ago, most of our problems is that the exponent of the numerator is bigger than the exponent of the denominator. And therefore, your answer will have positive exponent. So what happens if your denominator has an exponent that is bigger than the exponent of the numerator? So I'm just showing an example. 8 cubed divided by 8 to the 5th. So 8 cubed means 8 times 8 times h. 8 to the 5th is 8 times 8 times 8 times h. And so if we cancel the 3 h's, okay, the one on top, what we get is having a value 1 on the numerator, and what remains in the denominator is your 8 times 8, which is 8 squared. And so using the quotient rule, we are actually putting 8 cubed divided by 8 to the 5th is the same as 8 to the 3 minus 5. And 3 minus 5 is 8 to the negative 2. So it tells us that 8 to the negative 2 is the same as 1 over 8 squared. So you notice that if you have a negative power, this comes to the, okay, let me remove the, right. This rule of negative exponent, that if your exponent is negative, a to the negative n is the same as 1 over a to the n. So if you want to make your exponent positive, you put you put that in the denominator. So a to the negative n is equal to 1 over a to the n. So that's another rule, negative exponent. All right, so I think that's easy. Anything that you have negative, put it down. If your exponent at the bottom is negative, you put it up. We'll have some exercises later on. So I'll just continue with another rule of exponent. And this is now a product raised to a power. So like 2 times 3 cubed is 2 times 3 times 2 times 3 times 2 times 3. According to your associative, you can put together all the 2's and put together all the 3's, so that becomes 2 to the 3rd times 3 to the 3rd power, and we call that the power of a product rule of exponents, the power of a product. So this tells us that AB raised to the n, you just distribute your exponent to each of those a and b. So AB to the n is a to the n times b to the n. Power of a product. So therefore, like this example here, 2AB to the 7th is just raise 2 to the 7th power, raise a to the 7th power, raise b to the 7th power. So your final answer will be 128, a to the 7, b to the 7. So let me repeat, if you have a product and you're raising that product to a power, then you raise each of the values to that same power. A to the n times b to the n. Okay. And then, yeah, just continue with all these rules, and then we'll have some exercises later on. When we now have a quotient, raise it to a power. So it's just the same. You just raise the numerator to that power and raise the denominator to that power. We call it the power of a quotient rule, where you now have a over b raised to the n is just a to the n times b to the n. So an example is 2 over y raised to the fourth is the same as 2 to the fourth over y to the fourth, which is 2 times 2 times 2 times 2 is 16 over y to the fourth. Okay, so this is now the summary of all the rules. Okay, so we now have for the product rule, the summary is multiply numbers, the same base with different exponents, add the exponents. Quotient rule, divide common base with different exponents, subtract the exponents. Power, a certain number raised to a power raised to another power, multiply the two powers. Zero exponent, anything raised to the zero is equal to 1. And the negative, a to the negative n is 1 over a to the n. And if you have a product raised to a power, that power can be distributed to each of those values. So a times b to the n is a to the n times b to the n. And then the power of a quotient rule is now a over b raised to the n is just a to the n over b to the n. These different rules are really very important that would be we should be very familiar with, because in our future discussion we'll go back to these rules and apply this in many of the problems that we will be solving. Okay, so just to remember what we have done so far, will you please solve this different expressions? I have A, B, C, D, E, F. Try doing that.
That W or UV?
Yeah,
That's
2
UV.
UV to the second minus 2 raised to the minus 3. U, that's UV, yes.
W.
minus.
I'll give you a few minutes to work on it and then we will discuss. So, put together all the rules.
You're doing all? I think so.
We're doing all of them?
Yes.
Okay.
Yeah, you solve all them first and then I'll get your answers later on. And then I want the final answer to have positive exponents only.
Oh, okay.
Is that
I know.
Probably not. Oh, interesting. Yeah. Interesting. Oh, that's what it is. Oh. Oh. Hmm. Oh, 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 oh.
Done?
Yeah.
Okay,
No.
let's see. Oh, letter A. What's your answer?
We're not yet done.
Yeah, not done.
Oh, not yet. Okay.
Um, one sec here. Games out though. What? Oh, yes. No.
Okay, let's see. I think letter B is the easiest. What's your answer for letter B?
Well, for A or B?
B.
The
It's
letter B,
negative
yeah,
3.
letter B, because you don't need a lot of, except for
I
putting
thought all they
in
had
the rule of the product as well as the rule of negative exponent. What's the final answer for letter B?
Oh,
1 over
plus 1.
x
X.
squared of x cubed.
1 over x cubed. Are you okay? Yes. Reason is because x to the 8 times x to the negative 12 times x. You have now the exponent for your x is 1. So 8 plus 1 is 9. Then minus 12 plus 9 you'll get x to the negative 3. And so your final answer will be 1 over x cubed. Is that okay? That's for letter B. Okay. So actually what you did was x to the 8 minus 12 plus 1. And so therefore it will just be x to the negative 3. And that will now be 1 over x cubed. Good. Is that fine? All right. Now let's see with your number 1. Letter A. Who has an answer for letter A?
A.
Yeah.
2UV to the 6th power.
V to the 6th power.
To the 5th.
Then what happens to your 2 and your U?
2 to
Anyone?
exponent 2 exponents negative 3. Then the u also gets negative 3. And the v also to, okay, so the final answer, oh, I didn't do the final.
Let's see how you did it. This one is actually using the power product, the power rule in a way. Okay. So you distribute your negative 3 to each of the terms. So you begin with saying that will be 2 to the negative 3, u to the negative 3, v to the
That's,
negative 2 raised to the negative 3. That's the distribution, okay?
yeah.
So for each of your terms, 2uv to the negative 2, you distribute your negative 3 there as a power. So 2 to the negative 3, u to the negative 3, and then v to the negative 2 to the negative 3. So you'll now have supposed to be 2 to the negative 3, u to the negative 3, but b to the negative 2 raised to the negative 3 is v to the 6. That's why I'm hearing one of you say there is a v to the positive 6. Then what did we say? If you have a negative power, you
Take it
put
on
that in the denominator, right? So the 2 to the
Yeah.
negative 3 to make it positive becomes 2 cubed. Put it down. U to the negative 3 to be positive, put that down. What remains will be your V to the 6.
over 2.
Are we okay? And
Yeah.
so the V to the 6 is there. What is 2 cubed? 2 times 2 times 2 is 8, right? U cubed. That will be your final answer.
Okay.
Oh, please just ask questions if so it's following the rule of the power. Yeah, and then distribute, then do. So you begin from there, whatever is the one that had been raised to a power. Do not put that first going down. You can also do that, but it's good to put to change your negative exponents to positive after doing all the work towards the final, final step.
Okay.
Is letter A clear how it was done? Don't hesitate to ask questions. I just want to make sure that that is clear
Was
how to do it. No question on letter A. So for letter C, anyone who has an answer for letter C?
F. Exponent 4 over E exponent 4.
Is F on top or at the bottom?
There's no E.
Do that again? Okay. Okay, let
Oh,
me
be E
erase
to the-
all the. Yes, final. What's the answer?
So it would be e to the fourth
Over.
and,
I got F exponent.
there's
4.
no F because F on top would be -1 and the,
I got E to the fourth over F to the fourth.
I
All
got
right,
F.
E to the fourth over F to the fourth. Who got that answer?
I got
Me.
F.
E to the fourth over F to the fourth.
I got the opposite.
Okay, now we'll see, we'll see. Yeah, I think you had your answer opposite, but okay. I think one nice thing is first just distribute the power so that the power is already out. So E squared to squared, you got E to the fourth, right? Because that's positive. Then F to the -3 raised to the square, that will be -6. Is that okay?
Oh, that's how you do that.
Yeah, I mean, you are now multiplying. 2 times 2 is 4. 2 times -3 is -6. Over F to what power? -2, right?
It's not
So you are
negative 4.
multiplying the 2 to each of the powers. 2 times 2 is E squared, E to the fourth. F to the -3 to squared will be -3 times 2 is -6. F to the
Oh,
-1 multiply by 2, that's F to the -2. Because you distribute the power both to the product as well as the quotient. Both rule of the product and quotient. Is this okay?
Yeah.
Yes.
No,
All
for
right.
me, I negative. I saw negative on the exponent 2 on the equation.
Above the E or
No, that's E squared F to the -3 over F to the -1 squared. There's no negative on that power 2 there outside.
positive and negative.
Mine was negative.
That's why,
Sorry,
'cause
I'm
Yeah.
in a whole other language right now.
Is
I
that
didn't
how you
see
see
it.
it? There's no negative in the square there.
This year.
Sorry for okay. This one is not negative.
I have a question. I have a question.
Mine was negative.
What happened to the one?
Right.
Okay, I have
multiply.
I have a question. Okay,
What
what happened to
happened
the
to
one because
the-
okay, the -1 on
2
the
times
bottom?
-1 is -2. Okay, you say
Wait,
2
but
times 2 is 4. 2
Oh, the
times
-1
-3 is -6. 2
The
times
-1
-1 is -2. Are we clear?
Oh, it's F
What?
-1.
I'm so confused. I
Yeah,
thought that was
okay, let
F
me-
minus.
We are now dealing with the power. For every exponent, listen, for every exponent, multiply by that one that you are raising to a power.
Okay, I understand. Finally. I thought that, okay, so I thought that the -1 was an F minus 1 at the bottom, so that's why I
Oh,
was so
no, that's
confused.
F to the -1. All right. Okay. I think it was just not very clear. All right. So it's a power.
Thank-
Okay.
Okay, whew.
Sorry for that. All right. So is this okay now? E to the 4th, F to the -6 over F to the -2. Then what will you do now?
So you add, what you do
Yeah,
is to
what
get
you
the
can do is you now can put this down if you wish to, so that because that's a -6, all right? Or you can have -6 minus -2. But there are two ways of doing it. What you can do is you say e to the 4th F raised to the -6 minus -2, which is now e to the 4th F to the -6 plus 2 is e to the 4th F to the -4. And then you get e to the 4th over F to the 4th. Another way of doing it is put that F to the -6 down so that it will have a positive power. So you now have e to the 4th F to the -2 times F to the 6. If you now put it down. So F to the -2 times F to the 6, 6 minus 2 is 4. So just the same, you get e to the 4th over F to the 4th. Oh, please just ask. Please ask questions if something is not clear.
Yeah.
Is that
Yes,
okay? Yeah, do I can repeat if ever there's some point out which one seem not to be. So I hope that this first part is clear how it happened.
Yes.
Yes. Because we now distributed. Yeah. So 2 times 2 is 4. 2 times -3 is -6. 2 times -1 is -2. Okay?
Yep. Yep. Yep.
yes.
Good. So that's the final answer. E to the 4th over F to the 4th. Okay, now how about letter D? Oh, that one is
D.
D?
a little easy because you are just the same. If you have the same R, you know what to do with the exponents.
Is it
27.
27?
All right, you begin with 9 times 3, correct? So it will now be
Yes.
27.
7.
Good. Mhm.
Okay. Then R, and then is it 1 over S?
Okay, so it. Oh, what happened to my
That's
pen?
Am I wrong? Am I right?
Okay. 27 R
R, 1 over S?
over S. Did you get that?
Yeah.
I don't know why
Looks
my
like a
pen
5.
doesn't work now.
You gotta like give it little points, so it doesn't look like a 5. Still looks like a 5.
20. Okay, everyone, 27 R over S.
You mean 1 over S? Wait,
Yeah,
R over
you can put
S?
that 27 R times 1 over S, or we now say 27 R over S. My pen doesn't want to move. I don't know what happened. Okay, let me do it again.
7 R over S?
You get 27R?
I got 27 R 1 over S.
Yeah, 27 R times 1 over S, but that can be written as 27 R over S.
I get it now. Yeah. I get it. I understand. I understand now.
27 R times 1 over S, or 27 R over S. Fine?
Yes.
Very good. Yes. Look at letter E.
I got 1.
Okay. Yes. You got 1 for letter E?
Yeah. Am I right
Yeah,
or wrong?
I got
You're correct. This one is the easiest actually. Don't be you better be very what's that? Be very observant of what's happening here. You have 4/9, 4/9. T, T. W minus 2, W to the negative 2. They are the same.
Mhm.
Okay? This is the same expression. Then you raise it to minus 3 and 3. So the same expression, it will now be minus 3 plus 3 is 0. And what did we say?
Mhm.
Anything raised to the 0 power is
1.
1. Yeah,
don't
so
need to
if
worry
you were
about it.
just very observant, then you immediately can get the answer. We raise this to negative 3 plus 3 gives you 4/9 TW to the negative 2 to the 0 is 1. Whether the thing is very complicated, as long as it is raised to the 0 power, answer is 1. Very nice. Okay.
Yes.
Isn't that
We'll get there.
interesting? Okay. All
Yeah.
So our last number there. What? Anyone who has an answer?
I got 2, 8 exponential over 7.
Okay.
I don't know what I got. That one I wasn't sure.
You don't know what you got, huh? Oh,
Is it
let's
16?
begin with distribution. Let's begin with distribution, okay? So you now have 2 to the 4th, right?
Each 5K, 5
Oh,
8
draw.
to the
To the
8,
fourth.
correct?
Mm-hmm.
Yep.
K
Yes.
to
Yep.
the 4th, okay?
Fourth.
Over 7
Over.
squared, correct? 8 to the
Mm-hmm.
negative 2.
Oh,
Yeah, you
yes, yes.
multiply.
And
You
K,
multiply.
K,
Then
K to the
K
4.
to the 4th. Are you there?
Yes.
Sort of.
Yes.
Good.
Okay.
So to the 4th is 8. 7 squared is 49. Okay? I'll just put those numbers. That's easy to do.
2 to the power of 4
Then
is
8 to
16,
the
I think.
8 divided by 8 to the negative 2. Isn't that 8 to the 10?
Yes.
Yes. And then
I have a
K to the
question.
4th is the same as K to the 4th.
Slow now, yeah.
Oh,
Yeah, they cancel out.
very nice. So you can actually have your answer to, you can write that way, or you can also write it as 8 to the 10 over 49. Are we okay?
Yeah, I have a question. Can you hear me?
Yes.
2 to the 4th, is it 8 or 16?
Oh, sorry, why did I put 8? I was thinking of, sorry about that. Okay. Thank you. Sometimes you really just have to one thing with nice thing with the teacher, if you make a mistake, you erase.
You can break it.
Okay, let me erase this. So that's easy for a teacher. All right. If you are a doctor, if you make a mistake, the person will die. For a teacher, it's easy. Just erase the wrong answer. Thank you. That will be 16 and 16. Why did I put an 8? Okay. If you are a pastor, you make a mistake in giving your doctrine, what will happen to the person? Will be lost. Yeah. That's why I love to be a
Oh,
teacher. I make a
make
mistake,
it
I just erase and then do it again. And that's the way God does things, all right? When you make a mistake, just confess and
series.
accept it's a mistake. You'll be forgiven and you can make it right again.
Amen.
Yeah. I'm happy that I made that mistake. So I did a good. All right. How is it? So I think we are moving forward. Yeah. So anyway, once this one is just clear with you, as we move on to the rest of the lessons, when we multiply polynomials, divide, and do many things, yeah, you'll be using these rules, very important rules on exponents.
Memorize these things.
Very good. Okay. So, yeah, be familiar with those. So, I just want for the next few minutes, I just want to continue. Yeah, actually, I realized that my plan, I was very, what is that? Optimistic. I will move on, thinking that, yeah, my students have done some algebra in the past, but don't worry, I'll be very patient. We will move on according to your pace. I just want to make sure that things are understood. Okay. So we may be a little
If
bit behind, but I'll do that because I will maybe decide to just pick the ones that are very important for your life in our discussion here. Those some complicated math is not be very applicable. We might just not consider that wherever we get to that, but I'll make sure that whatever you will be needing in your career, we will be discussing in class. All right. So maybe just last thing about scientific notation. This one is just very similar to exponents. So I just want to proceed. Okay. I think you know the meaning of scientific notation. Many of the numbers, especially when the numbers are too big and too small, it is better to use scientific notation. And actually, even our calculators, when you now get values that are too big, that would not fit your 12-digit screen in your calculator, they give you scientific notation.
excuse
So,
us, ma'am.
yes?
So we actually have lunch right now, and then we have to go to work. So
Oh, yeah, yeah, Oh, I was thinking it's already 9:30. I'm very sorry about that. Now it's already 12:30 your time. Thank you for reminding me that. All right. What I'll do is I will put in the board the assignment. Okay, the assignment.
Okay.
Yeah. And by the way, regarding your reflective journal, please check the rubric, because it's important for you to know what I expect that you write in the reflective journal. And I want you to also give your reaction to the reading that I told you to read. All right. So thank you for reminding me. I think I just got overwhelmed. Okay. Have a good lunch and God bless you all. Okay.
Thank you. Have a good day.
All right. You too. Bye-bye. Okay.